Okay, so we'll move on. Both classes of compounds, CFC and HFC, have ability to produce chlorine-free radicals in the upper atmosphere. So we normally study this in our environmental chemistry for the depletion of ozone layer. And I have explained you some of the concept in the previous paper 2019. And before we have a discussion about these things in previous papers in the essay part. Okay. So this is true because CFC means chlorofluorocarbon. So chlorines are there, and at CFC also there is some components are chlorine. So in the structure, so they can form these free radicals. That is correct. Both classes of compound HFC and HCFC have ability to produce chlorine. So HFC means hydrofluorocarbon. So they don't have chlorine atoms. So this is wrong. All three classes strong greenhouse gases. So this is one of the consequences of even using HFC, because sorry, CFCs and HCFCs are typically the gases that can deplete the ozone layer. So instead of that, what we now use is HFC, which does not have the ability to deplete ozone layer. However, one of the consequences of this is HFC, even though it is not a gas that depletes the ozone layer, but also it is a greenhouse gas, so it affects for our greenhouse activity as well. So this is one of the important things that you need to remember. Okay, so C is correct. All three classes of compounds contribute significantly to ozone layer depletion. No, so I said you HFC does not contribute to the ozone layer depletion. But don't forget, it is a greenhouse gas. So it will surely contribute for global warming. So A and C correct, the answer is 5. Right. So we'll move on. Which of the following statement with regard to halogens and the noble gases and the compounds? Hypochlorous ion disproportionate rapidly in acidic solution. So if you remember this, I don't know if you remember. If you do not remember, so please go through this again and again, because hypochlorous ion does not disproportionate in acidic condition. It will disproportionate in the basic condition, right? If you do not know, please go through the resource book. This in the note, pretty straightforward. Okay, so I am not going to spend much time. Xenon form a series of compounds with F2 gas, among which XCF4 has a clear planar geometry. So xenon, there are 8 electrons. So if you get the structure of XCF4, so it would be like this basically. So you see here, this is a square planar geometry, no problem. Okay, so xenon form a series of compound. It is xenon form series of compound XCS4, XCF3, XCF2, yeah, but in general xenon is not formed because it's a noble gas, right? So for this particular statement, I would take this is correct. Among the hydrogen halides, HF has the highest bond dissociation energy per mole. So you can think about this, because HF will be the smallest one, right? HF, HCl, HBr, HI. You consider about the distances. So HF is very close to each other. So it should, I mean, the bond H and F is very small. So it should have the highest, right? So this is typically correct. Sorry. Boiling points of halogen increase down the group as a result of increasing the strength of the London forces. So this is very typical. Fluorine, chlorine, bromine, iodine. Fluorine, chlorine, gas. Bromine, liquid. Iodine, solid. Why? Because they have higher London forces, higher surface area. That is why their physical states also change from gas to liquid to solid, and there will be higher boiling point as well. Okay, so this is also correct. Basically, 3 answers are correct here. The real answer should be 5, but maybe they have taken this one wrong because the B statement, because of this one series of compounds. Because very rare, few compounds. There are only few compounds. Okay.